Okay, so as we continue with this video, we're going to look at simultaneous equations and then we're going to do the non-linear ones. So this document, if you want it, it's linked in the description. It's all fully hyperlinked and you can download it as a PDF. So this time it is going to say solve algebraically these simultaneous equations, and because it's non-linear we can't do elimination, so we're only going to do substitution. What I'm going to do is I'm going to rearrange this one to make y the subject so that y is equal to 3x plus 13. Then I'm going to substitute that into the top one. So we have x squared plus y squared, which is going to be 3x plus 13 all squared, and that is equal to 25. So this is a pretty advanced topic, so you're going to need to know how to do 3x plus 13 squared. Now you can write this out as 3x plus 13 multiplied by 3x plus 13, and you're going to do double bracket expansion for this that you've got here. That's going to give you 9x squared. 3 times 13 is 39, so you get a 39x. You're going to get another 39x, and then you're going to get 13 times 13, which is 169, and that's equal to 25. So we get 10x squared, 39 plus 39, that is 78x, and then 169 take away 25 is 144. And of course you can do any working out that you need to over on the side of the page, just to make sure you've got those numbers right. Now, before I try and solve this, I think you could notice that all of these are even numbers, including the 0, so you could divide everything in this equation all by 2. So if I half everything, it's going to make it a little bit easier. Half of 78 must be 39 because we added two 39s together, and half of 144 is 72. So now we need to go about factorising this. Remember, this is our value of a and this is our value of c, so we're going to try and find things that multiply to ac but add to give us b, add to give us that 39 then. So ac in this case is 5 times 72. Well, 5 times 70 is 350 and 5 times 2 is 10, so it's 360. So I'm going to think of some things that multiply to give 360, but they need to add to give 39. Well, 10 and 36 doesn't go so good because 10 and 36 is going to go to 46. And if I went lower, let's say I did like 1 and 360 or 2 and 180, they're going to be too big as well. So I need to make this number go a bit bigger. Now I could do 12. Let's see what happens if 12. 12 goes into 360. Well, 12 times 3 is 36, so it would be 12 and 30. Now, these are getting a bit closer. This adds to 42, but I want it to add to 39. I don't think that 360 is in the 13 or the 14 times table, but I think it is going to be in the 15 times table. If I do 360 divided by 15, 15 goes into 36 twice with 6 left over, and 15 goes into 64 times. So it's 15 and 24, and this is the pair that works because 15 and 24, they actually do add to 39, which was our goal that we had over here. So I'm going to just drag this and just sort of put that up here because we needed that to help us factorize. So now that you've got the 15 and 24, you take your 39x and you're going to split it up into those two bits. So we're going to get 5x squared. It doesn't matter which way around you do this, but you get a 15x and a 24x. You could do 24x plus 15x. It would give you something slightly different, but you still get the same answer at the end. Then all we need to do is also just factorize. So I'm going to take a factor of 5 out of the first part. You're going to factorize these first two things that we've got. So if I take a 5x out of this, I could take a 5x out of this and of this, I would get x plus 3. And if I take the highest common factor of this part, well, there has to be an x plus 3 in the brackets of the next part, and that means that it's going to be a 24 here, and 24 times 3 is indeed 72. If you're not sure about this factorizing technique, if you go on my page, and if you go to factorizing quadratics, you'll see it there. So we get one of the brackets is x plus 3, and the other bracket is 5x plus 24 equals 0. So this tells me that either x is equal to minus 3, and this one tells me that x is equal to minus 24 over 5. So if x is equal to minus 3, I'm going to use this one that we've got here to find out what y is equal to. Y would be equal to 3 times minus 3, which is minus 9, plus 13. So what I'm doing here in that yellow is connected to the yellow one at the top. And minus 9 plus 13 is 4. So we get, when x equals minus 3, y equals 4. Now we're going to do the slightly harder one, that if x is equal to minus 24 over 5, Okay, well this might be useful to have as a decimal. You might just find the calculations easier. So I'm doing 24 divided by 5. 5 goes into 20 4 times with 4 left over, and 5 goes into 40 8 times. So this is minus 4.8. And so y is going to be equal to 3x. So that's 3 times minus 4.8 plus 13. Well, let's do 4.8 times 3. 4.8 times 3. That's going to give me 24, and 3 times 4 is 12. That's 14.4. So that's going to be minus 14.4 plus 13, which is minus 1.4. So we've got this as one of our solutions that we have here, and the other one is when x is equal to minus 4.8, y is equal to minus 1.4. So we've got our two pairs of solutions for this one, and I don't think I've made any mistakes, but we'll soon find out when we go to the answers on the next page. So we have got minus 3 and 4, great, and then minus 4.8, which was our minus 24 over 5, and minus 7 over 5, that is minus 1.4, and so it doesn't have to be as a fraction, so that one's perfectly fine for us to have as minus 1.4. Okay, we've got another of them here. Prove algebraically that the straight line with this equation is tangent to the circle with this equation. So because it says prove, we're going to need some kind of statement at the end. Again, I'm going to rearrange this one to make x the subject. That feels easier. So I'm going to say that x is 2y plus 10. And I should say, really, to show that it is tangent, that just means that there is going to be one solution, because a tangent is where something like just kind of skims it in one place. If it was going in two places, then it wouldn't be a tangent. So this is kind of like graph theory that we've got here. So I'm going to substitute that x inside here. So that's going to be 2y plus 10 squared, that's my x squared, plus y squared equals 20. Now 2y plus 10 squared, if you need to write the double brackets out, that is fine, but you're going to want to start trying to do this without for squared things. So you're going to get 4y squared, you're going to get a 20y, you're going to get a 20y, you're going to get a 100. We've still got the other y squared, and we've got the 20 that was there. So the y squareds, there are 5y squared. We then get the 40y, and then the 100 take away the 20 is the 80. Now luckily this can all be divided by 5, including 0, because when you do 0 divided by 5, you get 0. So you get y squared plus 8y. This is a calculator one, but I'm going to do it without a calculator, and you get 16. Now, I'm hoping there's only going to be one solution, so this should factorize into a very special form, which is just going to be our y plus 4, y plus 4, because 4 and 4 times to 16, and they add to 8, so the only solution that we could get is if it's y plus 4 squared equals 0, the only solution is that y is equal to minus 4. Now, if y is equal to minus 4, then x is equal to 2 times y plus 10, that is grabbed from here. Okay, that's exactly the same statement that I've got. So that's minus 8 plus 10. Minus 8 plus 10 is 2. So we just need a statement to say, as there is only one solution, this means the line is tangent to the circle. This means the line x minus 2y equals 10 is atangent, I should say, or tangential, if I want to do it as an adjective, is atangent to the circle. So let's have a look at this one. So it's a proof. We did come up with this bit that we've got here, and then factorizing it, we get that y is minus 4 or x is equal to 2, and some kind of statement, so there's only one point of intersection, so the line is a tangent to the circle. Okay, this time we're going to do, again, there's going to be some substitution. I'm going to rearrange this one so that x is equal to 1 minus 2y. That's from here, and then I'm going to substitute that into the equation at the top. So that's going to be 2 lots of x squared. That's 1 minus 2y all squared minus y squared equals 17. Remember, if you need to do your 1 minus 2y as double brackets, that might help you, but I'm going to put it all in brackets because it's going to be doubled. So you get 1 times 1, your minus 2y or minus 2y, and the negative 2y times negative 2y is 4y squared. Now I'm going to double, well, I'll quickly simplify inside the brackets. That's 1 minus 4y plus 4y squared minus y squared equals 17. So that is now expanding this bracket for the beginning part. 2 minus 8y plus 8y squared minus y squared is equal to 17. Now, let's just simplify these. So 8y squared minus y squared, that's 7y squared. Then we have minus 8y, and then we have a 2 take away 17, and 2 take away 17 is negative 15. Now I'm going to use the AC method that we've got here. So that's my A, that's my C, and I want them to add to minus 8. So in this case, our AC is 7 multiplied by minus 15. So 7 multiplied by minus 15 is minus 105. So I need to think of things that multiply to minus 105, but they add to 8. Well, actually, there's a big clue already in the fact that 7 and 15 must be some factors, right? So if we want to think of things that multiply to that, that add to minus 8 but multiply to minus 105, well, minus 15 and 7 feels like a really obvious one that we've got because we already knew that they multiplied to 105. So what this means is you can take the minus 8 that's in the middle and we can split it into a minus 15 and a 7. Doesn't matter which way around you do this. So I'm going to split it as a minus 15y and a plus 7y. Minus 15 equals 0. We factorise the first part, which is the highest thing they have in common is just a y, which leaves me with 7y minus 15. And we need the second part to also have a 7y minus 15, which means it's just a plus 1 that we've got here. So the brackets are y plus 1 and 7y minus 15. This tells me that y is equal to minus 1, and this tells me that y is equal to 15 over 7, because we need that bracket to equal 0 or that bracket to equal 0. Now coming up here, if y equals minus 1, I'm going to use this rearranged thing that we have. I'm going to say that x is equal to 1 minus 2 lots of minus 1. Again, you could type this on a calculator, but that is literally just 1 plus 2, which is 3. So one of ours is x is 3 and y is minus 1. I've just put them in the order of the alphabet. Now I'm going to say if y is equal to 15 over 7, and this was the thing I was going to say, that's coming from this bit. Now I'm going to do again this yellow line here. It's going to be 1 minus 2 lots of 15 over 7, and this is perfect for us to put into the calculator. So I'm going to do 1 minus 2 lots of brackets 15 over 7, and we get minus 23 over 7. So we get x is minus 23 over 7 and y is 15 over 7. Now if you had time, you could obviously sub this back in to one of the equations, this first equation, and see that it works. But let's double check we've got this. So we've got the 3 and the minus 1 and the minus 23 over 7 and the 15 over 7 that we had here. Pretty complex kind of question. I liked factorising. You could have used the quadratic formula as well if you wanted to. Okay, I'm going to do some substitution for this one, and this one is not particularly pleasant because of these coefficients that we've got here, and then we've got one more after that. Okay, let's keep going, we're doing good. So this is luckily in a calculator one. I'm going to rearrange this one to either make x or y the subject. I'm probably going to make x the subject. So if I make x the subject, I would get that 3x is equal to 7 minus 4y, which means that x is 7 minus 4y over 3. And I'm going to sub that in to the first equation. So it's going to be x squared. That's going to be 7 minus 4y over 3 squared minus 4y squared equals 9. Now, I don't want to do this squaring in this kind of way. I'm actually going to just say this thing down here, when it's a 3 squared, it's going to become a 9. So I'm going to get 7 minus 4y squared over 9 minus 4y squared equals 9. And I'm actually going to get rid of this divide by 9 by multiplying everything immediately by 9. So I get 7 minus 4y squared minus 36y squared equals 81. And now I'm going to expand these. If you need to write the double brackets out, you should do, but I'm going to go straight in. It's going to be a 49 minus 28y minus 28y plus 16y squared minus 36y squared equals 81. So these bits came from expanding this double bracket. Now I'm going to do a lot of simplifying here. 16 minus 36 is minus 20y squared. Then I have minus 28y, which is minus 56y. And then I've got the 49, and I'm also going to subtract the 81. And this is where I am going to be lazy, because I don't like doing those kinds of numbers. I'm going to do the 49 subtract the 81, which is minus 32 equals 0. So just to clarify, I did those for my y squareds, those for my y's, and then 49 take away 81. Now, it looks like these things are going to have a highest common factor. They look like they're in the 4 times table, and I can get rid of the negative. So if I divide them by negative 4, so everything is being divided by negative 4, I would get 5y squared. I'm going to get rid of the negatives for both of these. When I do 56 divided by 4, again, I'm going to just use the calculator to check that I'm doing this right. I get 14y, and then I get an 8 for this last part. So to factorize this using the AC method that we've got, the AC that we've got here is going to be from the 5 and the 8, which is the 40. And I need to think of them that multiply to 14. Well, it's going to be 10 and 4, nice easy one, which means I can split the 14y into a 10y and a 4y, and then I can factorize the first and second halves. So the highest common factor here is going to be a 5y, so it's going to be a 5y brackets y plus 2. The highest common factor is going to be a 4, and that gives me, again, the y plus 2. So it factorizes to a 5y plus 4 and a y plus 2 equals 0. I'm going to go from here up to this top part. That tells me that y is equal to minus 2, or y is equal to minus 4 over 5. Now I'm going to use this to help me find out what x is equal to. So that's the bit I've been doing in yellow. So x is going to be equal to 7 minus 4 minus 2 over 3. And I'm going to be lazy, and I'm just going to put this in the calculator. So we're going to do 7 minus 4 brackets, let's do this as a fraction, 7 minus 4 brackets minus 2, it's doing the multiplication for us there, divided by 3, and x is 5. So we get x equals 5, y equals minus 2. And now for our next one, we're going to say that x is equal to 7 minus 4 lots of y divided by 3. So I can actually just go through my calculator, and I can change it from minus 2 to minus 4 over 5. You could type that in as 0.8, but I'm going to type it in like this, and we get that x is 17 over 5. So x is 17 over 5, and y is minus 4 over 5. Okay, let's just highlight the bits that were being copied from the substitution. There was that part and that part that we have there. Okay, so we have the 5 and the minus 2, and then they've got 3 and 2 fifths, that's 17 fifths, and minus 4 fifths. 17 fifths and minus 4 fifths. Okay, the last one, it says show algebraically they have exactly 1 point in common. So that means solve them simultaneously, and again we're going to do that kind of conclusion statement at the end. So when I rearrange this, y is equal to 5x minus 4. Put the 5x to the other side and the 4 to the other side as well. Then I'm going to take this y and substitute it into that y that we have there. So that 5x minus 4 equals x squared plus 3x minus 3. Now it's a quadratic, so I'll get it all on one side. So it's going to be x squared minus 2x, and then I've got the minus 3 plus 4. Minus 3 plus 4 is 1. And then this will factorize. You're thinking of two things that multiply to 1 but add to minus 2. Well, those things are going to be minus 1 and minus 1. In other words, this factorizes to x minus 1 squared. So this means that the solution is when this bracket is equal to 0, when x is equal to 1. And when x is equal to 1, I'm going to again use this bit that I'll highlight in yellow. Y is equal to 5x minus 4. So that's 5 times x minus 4. That's 5 minus 4, which is 1. So the coordinate where they intersect is 1, 1. So they intersect at only one point. Ooh, I should probably use the correct word. At only one point. And that point is when x is 1 and y is 1. So it does come up with a point with factorizing. We get this here for a statement confirming there is only 1 point in common. Now, these have some really hard bits. I would say probably the hardest bit is like this AC kind of bit of the factorizing. Otherwise, they're pretty formulaic. Rearrange one, substitute into the other, solve that quadratic. use the rearranged version to help you come up with these things, and they're usually going to be two solutions, so two pairs of solutions. If you found this helpful, it would be very, very useful for me if you could just drop the video a like, share this with some friends, and make sure you're subscribed to the channel, because I really want this to be shared with as many people as possible. I'm putting a lot of work into this, and I just want people to be able to use it and improve how they're doing with their maths GCSE. So good luck with all of your studies, and I hope you return for another video soon.